We'll go ahead and get started. And so we are going on a lecture. Today's topic is basically Node.js, right? So we're going to hit the MERN stack this semester, and everything is built on top of Node. So it makes the most sense to kind of start here. So if you want to open up the lecture outline, you can do that. But if you're kind of looking at a high level, what is Node? We're going to go through that today, kind of the objectives. We're going to cover what is Node. We hit last week of a JavaScript review. So we hit a lot of this already last week, at which point, we're going to kind of lightly touch on one thing that we haven't touched on, which is asynchronous programming. And then finally, we're going to write some council apps, right? So not the most lengthy lecture of all of our lectures. This one will be a little bit shorter because we spent last week kind of hitting the concept of JavaScript review. So what is Node? Well, we would start by answering that question by going to the Node homepage, Node.js.org. Okay, and so you guys go ahead and follow along here. Go to this homepage with me, and you can read the definition along with me. Node is an open source, cross-platform JavaScript keywords, right? Very important keywords, the last two words here, runtime environment. Okay, it's pretty simple the way I think of Node. Okay, when you learn JavaScript like me, right? You wrote some source code, and then you opened up your HTML in the browser, and that browser ran your JavaScript code, right? So we learned JavaScript executes in the browser, right? And that's our foundation of how JavaScript worked. It worked like that for a long time until it didn't. And someone built a technology on top of JavaScript to run outside of a browser. Right? A runtime environment simply allows you to run JavaScript out of the browser. Where does it run then? Right? If it's not running in a web browser, it's going to allow our server to run JavaScript. Right? So you've probably heard me say this before, but basically that's what Node is. Node allows JavaScript to run on a server. Now, even more foundational than that, I think it's really important that you guys just take a minute to understand, client-server architecture, right? A server, when you say that, I don't know that everyone really, knows exactly the point of a server, but simply put, a server is going to host a resource, and a client is going to access that resource, right? So when you have a web server, right, it's typically hosting HTML files, CSS files, JavaScript files. Like it has some resources, right? And then a client says, hey, I'd like that web page, right? So a server then gives the web page to the client, right? It's just a relationship. So I would start off by saying a client-server relationship is an architecture where a server has something that the client wants. The client would make a request for what it wants, and the server would then give the client the resource, assuming they had the permissions and the authorization to do so. Okay? So Node allows our server to host applications, right? Web applications. Okay? So again, keywords here, like if I'm etching anything in the brain, like it's Tuesday morning, 3-day weekend, like I understand it's early, but if I'm etching something in my brain right now, I would encourage all of you to etch that Node is a runtime environment that allows JavaScript to run on a server. So essentially what was done, Node was built on top of the JavaScript engine that was built into Chrome, right? You might have heard that by now. V8 engine is in Chrome is the engine that basically executes your JavaScript. Okay, so built into Chrome was this software called V8, right? Kind of a cool name. Obviously the point, big, powerful engine. If you know anything about Chrome, you probably know that Chrome is a resource hog. How many people know that? Chrome's a resource hog, takes up a lot of computer RAM, right? But you also probably know that Chrome's reputation is speed. You heard that one before? Like, what is the benefit of using Chrome? Its reputation is that it's fast. Why is its reputation that it's fast? Primarily because of this V8 engine. It's because of this V8 engine that executes JavaScript really fast, faster than other browsers. Okay, Internet Explorer had a different engine, Firefox had a different JavaScript engine. They all have different names. Suffice to say, Chrome had the fast JavaScript engine. Therefore, Chrome became fast because it executed JavaScript fast. Like, that's really what it boils down to. Node is built on top of this same V8 engine. Okay, AKA it executes fast. Now, last week, did I have you guys download the latest LTS? Okay, if you haven't yet done that, go ahead right with me right now. Go to your command prompt. If you start CMD and type in node/v, and you should see something like 18.17.1. Can everyone do that real quick and just make sure?
Really did change over 2 years.
Yeah, I mean, well, 18.17.1. What did you have on yours?
18.17.0.
Yeah. So it did probably not that long ago. If you do npm version, this one's not as critical, but just out of curiosity, what is your version? Same as mine?
9.8.1.
That's fine. That's fine.
Upgrade to 0.1 of Node.
The important thing here is that we all have a similar Node version. Again, this is going to allow us to run JavaScript outside of a browser, right? Outside of Chrome. So let's go ahead and do that. Let's just get a hello world inside of a terminal, right? And we'll do that by writing, and again, you can just follow along. This is just lecture repo, so it doesn't have to be anywhere specific on your computer, but go ahead and create a new folder, and I'll just call this the Node lecture folder, and then I'll open this up with VS Code. And let's go ahead and create an index dot and MJS, right? Remember, this is the ES6 file extension that is modules, right? That enables modules. So okay, and hello world from Node.js. And then, let's see if I go to, now, let's see if I can zoom out just a tad bit. Hotkeys. If I hold Alt and scroll, Alt and minus, there we go. If I hold Control minus, I can kind of zoom out a little bit. The reason, if I zoom into where I was, I get these 3 dots to get to my terminal. I didn't want to do that. So I'm going to hold Control, press the minus key. Now you can kind of see this terminal window, right? So go ahead and open up a new terminal. Right, you can see this opens up a PowerShell terminal. PowerShell is a power user's command prompt, right? So it is a very similar command line interface, but you have access to a few more commands in PowerShell than you have access to inside of the typical CMD terminal. Now, this terminal, if you want to kill the terminal, it's not going to hurt anything, right? That terminal closes. New terminal. If you ever close this terminal, right? If you do file new terminal now, notice I have two terminals open, right? So I'm just getting a lay of the land here, right? So we have two PowerShell terminals. We don't need that. Like if you close these, if you open up a terminal and then like you click this X, close the panel, you should be able to view the terminal at this point without opening up another one, right? So off of view, yes sir.
What does the M and MJS stand for?
What does the M in MJS for? Well, I'm gonna go out on a limb without 100% certainty and say module, right? But I'm going to say module, but double check my answer here. What does MJS? Module JavaScript. Yep, module JavaScript. I was fairly certain, but double checking my answer is always a good thing. Okay, so hello world from Node.js. Now, okay, Node should be a recognizable command. It might not be recognizable. So like if this doesn't work for you guys or if it doesn't work for me, we have to make it a recognizable command. Now notice I'm gonna start by typing the command node. And then I'm going to type in the file name index. If I check IN, if I start typing it and then I hit tab, right, here's a fun little auto-complete feature inside of a command prompt. You should get something like, you know, current directory /index.mjs. And it did work. Hello world from Node.js. The question is, did yours work? No. Some people say yes, some people say no. Cool. There's a reason for that if it didn't work. Did it say unrecognized command? What did it say?
I didn't even when I hit tab.
Oh, okay. We'll just type it in manually then. If you hit tab and it didn't work.
Would that have worked if we didn't do MJS and just normal JS file?
Yes.
Okay.
Yeah, so.
I don't really understand the difference, I'll be honest.
Yeah, okay, so good question. Like, would it have worked if we just had a normal JS file instead of an MJS file? And Tony says, the difference is unclear. Remember when we were importing and exporting things last week, right? To be able to do that, we have to have an MJS.
Oh.
Okay, now, depending on how you link to it, if like you link to it and you say that this is a module, if you don't specify somewhere that this is a module, then you're not gonna be able to import and export. So like the important thing here is that somewhere in your code, you have to specify that this is a module JavaScript file. For right now, it's not important. Like if I were to say main.js and console log hello world from main.js, and now I do node main.js, okay, it's still gonna work. Okay, so right now, I didn't have to do the MJS, but if you want to use some of the newer features, somewhere along the way, you have to specify a module. Okay? Yep. And even if you can use the newer features with these .js, but somewhere in there, somewhere in our code, we have to say the type of module. And there's other places to do that. Does that make sense? Okay. So far, so good, right? So you good, Atticus?
No, I didn't do so.
It still didn't.
Cannot find module.
Okay, let's take a look. So just getting used to Visual Studio Code again because it's been a while. If I change my hello world from Node.js, I'm just gonna put my name here, right? So I'm gonna say by Evan Gudmested. Okay. This little dot right here means your file is not saved, right? So another kind of common little thing here is if I don't save this and I go back to run it, notice it's not giving me my name. Let me go to index. See, it's not updating, right? So when you have changes to save, you're going to see that little dot. Of course, Control S is the hotkey to save. And then now when I run, and by the way, hotkeys, if I press the up arrow in my terminal, it goes back to the last command, right? So if you're not familiar with the hotkey, press up, you press up twice, it'll go to the prior command. Right, now that I save my changes, press the up arrow, enter, we're getting those changes. Okay. So what does this allow us to do? Well, the first place to start, where we start in this class, is we write console apps and we run them in Node. Remember in C#, we built some console apps and then we built GUIs, right? We start, like literally, there's one lab. There's one lab that we do in this class where we start writing JavaScript in the console. And so, we can do things in these files to ask the user for input. And so we can build out some console apps, right? Like you have the foundations to do that. There's one more thing that I want to introduce, and that's the concept of asynchronous programming, right? So asynchronous programming, if I, of course, pull in my best friend here, the MDM web docs on asynchronous programming. Asynchronous programming, right? So synchronous obviously means at the same time, and we've been writing synchronous code. Pretty much it executes top to bottom, and before it executes, line 2, it's going to finish executing line 1, right? So it's going to execute line 1, then go into line 2, and then go on to line 3. Of course, we have loops and we have conditionals that modify the flow. Okay, but for the most part, our code has been executed top down, top to bottom. That is limiting when you start working with other resources, such as database, right? We're going to obviously be working with databases. When you start working with, well, for example, if you were to do file I/O and work with a local file system, there's a lot of situations where you kind of like, you start a request and then you got to kind of wait for a response. And in that downtime, I mean, is anybody a server, right, at a restaurant? Anybody? Yeah, a couple people? Okay. So, the example of a restaurant example would be as a server, you're a single thread, if you will. You're a single worker, okay? And you go take an order from a customer, and then you put that order into the kitchen. And then if you were to wait for that order to be done and then deliver that order, right, you have a lot of downtime, suffice to say, right? So that's not the most efficient way to run, right? Obviously, as a server, you might go take another order, go clean or bus a table, right? And so you don't have to wait kind of for every execution step by step to finish executing if you're writing code in an asynchronous format. In other words, you can put an order in, you can start a task, and then you can go complete some other tasks, right? And then when you get the food delivered, when the data comes back from the database representing the food, then you can deliver that food back to the table. Okay, so asynchronous coding allows us to write more efficient code. If you think of a worker as a thread, and that thread no longer has to wait for everything to complete one line after the next. It kind of releases that thread to go do something else. They could go take another order, so on and so forth, continue executing until you get a response back. Now, when it comes to asynchronous JavaScript, okay, I'm going to recommend that we go through this article in detail, but let's kind of take this at a high level. In this module, we take a look at asynchronous JavaScript, why it is important, and how it can be used effectively to handle different operations, such as fetching resources from a server. Asynchronous JavaScript is a fairly advanced topic, and you are advised to work through the first steps in the building block modules before attempting this. Okay, so here, this first article, Introducing Asynchronous JavaScript. In this article, we'll learn about synchronous and asynchronous programming, why we often need to use asynchronous techniques. Okay, so I guess that's just something to point out. You don't always have to execute code asynchronously. It depends on the task. So when, for example, in the most common scenario, when you're working with databases, we're going to write asynchronous code, right? But we're not always going to write asynchronous code. And the problems related to the way asynchronous functions have historically been implemented in JavaScript. Okay, so again, allow me to go into this because I think it's beneficial to kind of take this from a grassroots and kind of get into the weeds on this. Okay, now high level, here's what I would take away about asynchronous programming. High level, there's kind of 3 ways in JavaScript to implement asynchronous programming, and we're going to focus on one of the 3 ways. Okay. There's this thing called callbacks. We're gonna do a little bit of all this, but there's callbacks. And if you've ever written jQuery, you're probably very familiar with callbacks, because callbacks were a very common concept in jQuery. That's where I originally learned them. There's promises, right? Promises are a second way to implement asynchronous programming. And then there's something called async await. And async await is the easiest syntax. It's the easiest to learn, and that's what we're going to use kind of to get started, is async await. So like high level, like what would I take away after today's lecture? I would hope that you would take away that there are certain conditions in JavaScript that make sense to write this kind of asynchronous programming that's not exactly top bottom, line by line. One of those conditions is databases. And so, or why are we talking about this already? Because we're not talking about databases yet. We're going to use asynchronous programming when we accept input from the console. In other words, you're going to prompt the user for some input, and you don't know how long it might take to get that input back. So you're going to release the thread, you're going to release the worker to kind of continue executing, doing other work until the user gives you the feedback that they want. Okay, so we're actually going to write async await today. And you're going to see that's a style to implement asynchronous JavaScript. In this article, we'll explain what asynchronous programming is, why we need it, and discuss some of the ways asynchronous functions have historically been implemented in JavaScript. Okay, asynchronous programming is a technique that enables your program to start a potentially long-running task and still be able to be responsive to other events while that task runs, rather than having it wait until the task has finished. Does everyone generally understand that concept? right? The whole like being a server, I think, is very relatable. Like you're gonna put your order into the kitchen, you don't want to wait for the cook to cook the food so that you can deliver it, right? You're gonna probably do some things in between.
Instead of one cog, it's multiple cogs.
One cogs, multiple cogs. I can get with that, right? So once that task has finished, your program is presented with the result, right? So once the data comes back from the database, you get the result of that database call. Many functions provided by browsers, especially the most interesting ones, can potentially take a long time and therefore are asynchronous. For example, making an HTTP request using fetch. We use the fetch API, right? The fetch API works with what are called promises, right? You might remember that from last week when we used the fetch API to read a JSON file. Accessing a user's camera or microphone using get user media, asking a user to select files, right? So here, let's talk about this, right? Fetch typically works with other data sources, right? So the fetch API uses promises, so you don't know how long it's going to take to get that data back. Kind of the same thing here, typically if you're saying, hey, let me use the user's webcam, they might have to agree. They might have to click accept to allow your application to use the webcam, right? You don't know how long that's going to take, right? So you kind of want to free up the worker, free up the thread, if you will, to go do other tasks. Same thing. If you say, hey, upload your image to the social media site, right? You're going to allow the user to open a file picker, and they're going to have to browse because they don't know where their photos are. They're going to have to browse their computer. That might take 1 minute. That might take 10 minutes. You don't know. So even though you may not implement your own asynchronous functions very often, you are very likely to need to use them correctly. In this article, we'll start by looking at the problem with long-running synchronous functions, which make asynchronous programming a necessity. All right, so here's synchronous programming. Again, think one task at a time, synchronous programming. So here we got a greeting, console log greeting. All right, so pretty straightforward. Outputs the JavaScript greeting to the console. We should note here, so this is what we're used to writing, right? This is synchronous. We should note here that the browser effectively steps through the program one line at a time in the order that we wrote it. At each point, the browser waits for the line to finish its work before going on to the next line. It has to do this because each line depends on the work done in the preceding line. That makes this a synchronous program. It would still be synchronous even if we called a separate function, right? So even though we're making functions here, this is still going in order top to bottom. This function call then executes this function right here and then comes back and runs the console log. Make greeting is a synchronous function because the caller has to wait for the function to finish its work and return a value before it can continue. What if a synchronous function takes a long time? The program below uses a very inefficient algorithm to generate multiple large prime numbers when a user clicks a button. The higher the number of primes a user specifies, the longer the operation will take. And so here's just a little bit of JavaScript, a little bit of HTML. They click a button and it generates a prime number. What's a prime number?
Only divisible by itself in 1.
Only divisible by itself in 1. And so if you say, give me the first 1,000 prime numbers, it's going to take a while to calculate all those prime numbers, right? Is the general idea. So a little bit of JavaScript logic here. Try clicking the generating primes. Depending on how fast your computer is, it will probably take a few seconds before it displays finished. Give it a shot, click. I've got a fast computer. Okay, so you saw the delay, right? It's not the fastest thing in the world. What about you guys? You guys following along? Taking a little bit longer? A couple of people say, sure, took a little bit longer. The trouble with long-running synchronous functions. The next example is just like the last one, except we added a text box for you to type in This time, click Generate Primes and try typing in the text box immediately after. You find that while our Generate Primes function is running, our program is completely unresponsive. You can't type anything, click anything, or do anything else. So try typing in here immediately after pressing Generate Primes. And I'm clicking in here and it's not responsive. Right? So I was trying to execute the task while the JavaScript was running and my page was unresponsive. This is the basic problem with long-running synchronous functions. What we need is a way for our program to start a long-running operation by calling a function, have that function start the operation and return immediately so that our program can still be responsive to other events. Is this making more sense? Hopefully it is. Notify us with the results of the operation when it eventually completes. That's precisely why asynchronous functions can do. That's precisely what asynchronous functions can do. The rest of this module explains how they are implemented in JavaScript. Okay, so I kind of already talked about callbacks being one of the ways. Then I mentioned promises. Then I mentioned async await. But they start with this concept of an event handler. So let's kind of start here. The description we just saw of asynchronous functions. By the way, I promise this class is not just me reading MDN to you the whole time. That's what today kind of is, but we're going to get past this, right? And we're going to write a lot of code. But I found, when I went through these articles, I found them very useful. And the only way I can ensure that you go through them is by doing this a little bit. So here we go. The description we just saw of asynchronous functions might remind you of event handlers, and if it does, you'd be right. Event handlers are really a form of asynchronous programming. You provide a function, the event handler, that will be called not right away, but whenever the event happens. If the event is the asynchronous operation has completed, then that event could be used to notify the caller about the result of an asynchronous function call. So I guess, yeah, I didn't think of it that way, but event handlers are, I guess, another way to implement asynchronous programming. I kind of forgot about that piece. Event handlers are really a form of asynchronous programming. You provide a function, aka the event handler, that will be called whenever the event happens. This is where if the event is the output, the asynchronous operation has completed, then that event could be used to notify the caller about the result of the asynchronous function call. Some early asynchronous APIs use JavaScript events in this way. Okay, so this XML HTTP request, if you ever learned Ajax, you've used this object before. So this was an object used to implement asynchronous JavaScript and XML, aka Ajax, for a long time, right? So this object API enables you to make HTTP requests to a remote server using JavaScript. Since this can take a long time, it is an asynchronous API, and you get notified about the progress and the eventual completion to a request by attaching event listeners to the request object. So the following example shows this in action. Click to start request to send a request. We create a new basically XML HTTP request object and listen for its load end event. The handler logs finished along with the status code. After adding the event listener, we send the request. Notice after this we can log start request. That is, our program can continue to run while the request is going on, and our event handler will be called. So this is basically reformatting that code asynchronously using this XML HTTP request, which is, using basically these event handlers way of writing asynchronous code. This became a little bit more complex. Click to start request. And there we go. Happens finishing. Now it doesn't show that, kind of like it was before, that you can still interact with the page. This is just like the event handler we've encountered in a previous module, except that instead of an event being a user action, such as a user clicking a button, the event is a change to the state of an object. Okay, so I don't really think of event handlers as a way to implement it, but maybe I need to, because as they demonstrated, that is one way that asynchronous programming can be implemented. Okay, next up is a callback. Now the definition of a callback you can kind of read that, is not intuitive, I would say. An event handler is a particular type of callback. A callback is a function that's passed to another function with the expectation that the callback will be called at the appropriate time. So the best way I can describe callbacks is when I was learning jQuery, a callback would say, hey, run this function as soon as the prior function completes. And so it's like, hey, you would pass a function, you would say, and you guys have used callbacks, by the way, when you did set timers and set intervals, right? Set timers and set intervals, if you remember the JavaScript class, you've used a callback. And it basically said, hey, call this function after 5 seconds, right? You can do that one time, that's a timeout, or an interval would be multiple times. As we just saw, callbacks used to be the main way asynchronous functions were implemented in JavaScript. The problem with callbacks have a problem. Their syntax is not the most friendly, right? So callbacks do not have a friendly syntax. And because it was unfriendly, a lot of times you would end up having multiple callbacks all nested inside of one another. So inside of a function, you would have a second callback. Inside of that callback, you'd have another callback. Inside of that callback, you'd have another callback. And it created, a very common term of what's called callback hell. Have you guys heard of callback hell before? First time hearing that term? Okay. Callback hell is the reason why callbacks are not the primary way that we handle asynchronous coding anymore. It says, however, callback-based code can get hard to understand when the callback itself has to call functions that accept a callback. This is a common situation if you need to perform some operations. Okay, so here we've got one function. Here's another function, do step 2, 3 functions. So this is implemented in a synchronous method, right? So here's 3 functions. Here we're implementing these in a synchronous method. Okay. Take a look at this same this is using callbacks now, right? So to take this operation, everyone can take a look at this. Zone in for me just for a second, okay? This is the short version about callbacks. Okay, we're not going to write a lot of callbacks because this is a problem with callbacks. Okay, this is a synchronous, 3 different synchronous functions, executing them one at a time. Notice how this is done, how you have to code this in a callback syntax. This is callback hell. Okay, notice here we say, hey, we're going to do step 1. And then inside of do step 1, we're calling do step 2. And then inside of do step 2, we're calling do step 3. So these are all nested function calls within one another. And so here, it's going to execute this one first, pass result 3 into do step 3. Let's see, do step 1, passing result 1. Yeah, see, it's confusing. AKA,
Is it basically just sent the 0 to the console log and make step 3 or whatever?
yeah, let's see if I can, I mean, you have to follow what this does,
Okay. Oh, I get it.
right? You have to follow what each one of these does. Yeah, so whatever these do, that's not the point that I want to make, because we can trace it and figure out exactly what it's doing. But just notice the syntax here. The syntax is not friendly. Okay, and these are simple functions, right? When these functions become more complex, for these reasons, most modern asynchronous APIs don't use callbacks. Instead, the foundation of asynchronous programming in JavaScript is the promise. Whoops. And that's the subject of the next article. Okay, so we kind of talked about callbacks and really their shortcomings, and so now promises, which are more commonly used, as you will see. Promises are the foundation of asynchronous programming in modern JavaScript, right? So definitely worth getting familiar with these things called promises. So what is a promise? A promise is an object. So I kind of like start there, right? A promise is a JavaScript object that is returned by an asynchronous function. So it's an object that is returned from an asynchronous function, which represents the state of an operation. There's some different states that we're going to talk about, but there's not many, right? I think there's 3. When the promise is returned to the caller, so again, this is a function call. When the promise is returned to the calling function, the operation often isn't finished. But the promise object provides methods to handle the eventual success or failure of that operation. Okay, so again, this is an important part as well, right? You're going to have a promise, but a lot of times you're not done, the operation often isn't finished, as it says. But then there's some functions that you call that will say, okay, now you call this function and I can actually get the data that's promised, right? So promise is kind of like exactly that. It's an asynchronous function that's saying, I'm going to give you this. It is. I promise this. It is a promise for an eventual getting of something, right? Eventually, you're going to get something when you call this promise. Okay, they talk about callbacks and why they're not great. With a promise-based API, the asynchronous function starts the operation and returns a promise object. Remember, the promise object is not the data itself, right? It's an object, it's a promise object, but you still have to call another function to get it. You then can attach handlers to the promise object, and these handlers will be executed when the operation has succeeded or failed. Okay? So a promise is an object. You're going to have this object. You're then going to call a method on that object, and you're going to get the data. That's basically the way that we're going to work with promises. We did this already using the Fetch API last week, so let's kind of go through this. In this article, we will explore promises by copying some code samples. To set this up, open example.org. In that tab, open the JavaScript console. When we show an example, copy it into the console. You will have to reload the page each time you enter a new example, or the console will complain that you have redeclared the fetch promise. In this example, we will download the JSON file. So there's a JSON file that's kind of out there. There's a JSON file. And log some information about it. To do this, we will make an HTTP request to the server. In a request, we send a request message to the server and it sends us back a response. In this case, we will send a request to get a JSON file. Remember in the last article, we made requests using this XML HTTP request API. In this article, we'll use fetch API instead, which is the modern promise-based replacement for this old XML HTTP request. Copy this into your console. Okay, so here we're just basically copying the script into the console. Okay, let's examine this. Okay, first line here, as it kind of says, this is our promise. This is a promise object. So this line creates an object. Keep in mind this object is not the data itself. Like we're trying to get to this JSON, right? But this object is not the data itself. You're going to notice it's going to log the fetch promise, which is not the data. Okay, this is a promise for the data. It's like, hey, I'm going to. We then call the then method on my fetch promise. So this is the method. We can get access to the data. It says here then response console.log response.status, and then the console.log says started request. So you can kind of see here it's going to log this. It should log this and then log that. Let's hit enter. So you can see this first console log is this promise of a pending state. Then we have a started request. So this console log says this promise. Then a console log started request. Remember, this is asynchronous programming, so it's like, hey, I'm kind of waiting on the data, so go ahead and do this line next. And then you get receive response 200, which is this console.log right here. So this calls the fetch API. Now, ultimately, we're not actually showing you the data. It's just giving you a status code of status code 200, which is success. We're going to talk about status codes and all the different ones. Now, there is this interesting undefined, which kind of glancing here, I'm not seeing where the undefined is jumping out at me. So let's see if it explains it or what's going on here. So here we call the fetch API and return the value to the fetch promise variable. So this fetch promise, this is our promise, right? This calls the fetch API. It's pretty straightforward. It's kind of built in. You just got the keyword fetch. So this returns a promise object into this variable. Immediately after logging the fetch promise variable, the output should be like the state is pending, telling us that we have a promise object and it has a state whose value is pending. Remember, there's a few different states that we're going to talk about. Pending is one of them. The pending state means the fetch operation is still going on. Passing a handler function to the promise's then method when and if the fetch operation succeeds, the promise will call our handler, passing a response object which contains the server's response. So again, this is in a successful retrieval of the data. We run this then method and get a response from the server. And that response object has a status of 200. So you see here, that's the output. Again, kind of interesting. Not exactly what I got, because I got this extra undefined, which is not necessarily important, but I also don't know where it's coming from. That's a little intriguing where that line is coming from, but that's okay. Results may vary, but we got the theory, right? That's the important part right here. Is we're getting down some theory. Note that the started request is logged before we received a response. Unlike synchronous function, fetch returns while the request is still going on, enabling our program to stay responsive. Now, just to change this, if I were to change this source code a little bit and paste this, like let's just look at the whole response object. And I think there's a response.data. So here it's trying to do a console log. Let's change this again. Let's paste this in. And instead of doing a console.log, I'm going to do a console.table. You guys remember the console.table will kind of show us in a table format an object. And no, didn't want to do that either. Let's refresh again. I'm just trying to get to the data. Let's see, response.data. No. Not that this is important, but I'm going to response.json. There we go. Let's try that. That's what it is. Paste as plain text. Response.json. Something like that. No. Okay. Not important. Chaining promises. Okay. With the Fetch API, once you get a response object, you need to call another function to get the response data. In this case, we want to get the response data as JSON. We would call the JSON method. That's what I was just doing. It turns out that the JSON is also asynchronous. So in this case, we have to call two successive asynchronous functions. And there, okay, that's what it is. I needed to create a JSON promise. That's what I was going for. Clear it out, paste it in. JSON is also asynchronous, so you store that in a variable, and then we get some data back. Data sub 0, right? Data is our array, sub0.name. Let's kind of refresh this if we were to paste it again. Just tinker with this, data sub 1. We get hot dogs, so on and so forth. Right, so we kind of nest some promises in there. But wait, remember in the last article where we said that by calling a callback inside of another callback, we got successively nested levels of code. And we said that this is callback hell, made our code hard to understand. Isn't this just the same? It is, but the elegant feature of a promise is that the then method itself returns a promise which will be completed with the result of the function passed to it. This means that we can, and certainly should, rewrite the code above like so. And so here you have these successive .then calls. And so this syntax is a little bit cleaner, right? So here's, let me kind of clear this out. Here's kind of like V1, version 1. And here is version 2. You see it's a little bit cleaner. When we have this then method, we get a response. Then.json, or response.json, this is returning a promise. So then you just chain a then method, which gets you access to the data. So the syntax is a little bit more concise here. Instead of calling the second then inside the handler for the first then, we can return a promise by JSON. We call the second then. This is called promise chaining, and means we can avoid ever increasing levels of indentation when we need to make consecutive asynchronous function calls. Before we move on to the next step, there's one more piece to add. We need to check that the server accepted, was able to handle the request before we try to read it. We'll do this by checking the status code and throwing an error if it wasn't okay. So here on this one, you can kind of see that we're starting to consider what happens if we don't get the data. And here you can see if the response is not okay, you know, throw an error message. Otherwise, log. Now this is not a typical necessarily way on how we're going to catch errors. We're going to have a catch block, right? So that's where catching errors comes in with these promises. This brings us to the last piece. How do we handle errors? The Fetch API can throw an error for many reasons. You know, for example, no network connectivity or a bad URL. And we are throwing an error ourselves if the server returned an error. In the last article, we saw that error handling can get very difficult with nested callbacks, making us handle errors at every nested level. However, to support error handling, promise objects provide a catch. So you guys have worked with catch blocks before. Promises have a catch block that is meant for handling errors. The catch block is a lot like the then. Remember, the then block is for success. The catch block is for errors. And you call it a handler function. However, the handler is passed to then is when it succeeds. The handler passed to the catch is when it fails. Simple enough. If you add a catch to the end of the promise chain, it will be called when any of the asynchronous functions fail. So you can implement an operation as several consecutive asynchronous function calls and have a single place to handle all errors. Right? So what they were kind of saying is, hey, the way that they were coding it before, you might have to nest a bunch of error handling like every level, but this is just like a single catch block to handle all the errors. So you can see here, here's our promise object. Here's a successful block of response. And here, they are catching errors. Now here we're manually throwing an error and we would catch it right here. And if we try running this version, you should see the error logged. Now, let's clear this out, refresh, and paste. And it says fail to fetch. So that would be the error that was caught by our catch block, which again kind of keeps it from our JavaScript crashing. Keep in mind, when you handle your errors, it stops the program from crashing. And so promises, these are promises. I mean, I hope you guys are, you know, still sticking with me a little bit, because we use async await, which uses promises. So you got to get the foundation for you to use async await. Okay, promise terminology. Promises come with a specific set of terminology that is worth getting clear about. First, a promise can be one of three states. We talked about states: pending, fulfilled, and rejected. These are pretty well self-explanatory, but let's go through them. The promise So pending. The promise has been created, and the asynchronous function it's associated with has not yet succeeded or failed. This is the state of your promise when it is returned from a call to a fetch and the request is still being made. So, we saw that, right? We saw that in the first example that the state was considered pending. If the promise becomes fulfilled, that means that the asynchronous function was successful. The promise is fulfilled, and then the then handler is called. Of course, if it's rejected, the asynchronous function has failed. When a promise is rejected, the catch handler is called. Note that what succeeded or failed means here is it's up to the API in question. For example, the fetch considers a successful request if the server returns an error like 404 not found. So it's up to the calling block of code to determine what is a success and what is a fail. So it's interesting if you guys kind of read this bit. Fetch considers a 404 not found success, but not if the network error prevented the request from being sent. Sometimes we use the term settled to cover both successful and rejected, right? Fulfilled and rejected. A promise is resolved if settled, or if it has been locked in to follow the state of another promise. Almost there, almost there. Combining multiple promises. The promise chain is what you need when your operation consists of several asynchronous functions, and you need each one to complete before starting the next one. But there are other ways you might need to combine asynchronous function calls, and the promise API has some helpers. Notice that this is a promise all. To kind of skip to the example, here's 3 promises, and here's a then block that waits for all 3 of them to successfully resolve. So you do promise all 3 of our promises, then catch, again, success block, failure block. So this is a way to handle 3 promises being successfully resolved. But if one of our URLs is not found, it would run the catch block. Okay, finally to what we're going to use. Okay, keep in mind, so here's what we're going to use on our labs as early as today. Async and await. We will be using this all semester long. The async keyword gives you a simpler way to work with asynchronous promise-based code. So you got to understand promises to really understand async. Adding async at the start of a function, obviously makes it an asynchronous function. So here we're declaring a function asynchronous. Inside an async function, you can use the await keyword before a call to a function that returns a promise. So that's why it's called async await, right? The function here is asynchronous. The await keyword is going to be put before the function call that is an asynchronous function. This makes the code wait at that point until the promise is settled, at which point the fulfilled value of the promise is treated like a return value. TLDR, like, give me the short version. Why are we going through all this detail? When you use async await, it looks a lot like synchronous programming. Async await looks a lot like asynchronous programming, but it's not. It is asynchronous code, but it's just the syntax, because it's built on top of promises, which are ways to execute code asynchronously. And so again, this await keyword, like for those of you taking notes, make a note on await. await is put before a call that returns a promise. So up here, fetch was returning a promise, right? So let's kind of see here, we're making a function asynchronous. If you're going to use the await keyword inside of a function, that function has to be marked as asynchronous. Okay, you cannot have this keyword inside of a function if that function is not marked async. And so this is here. This is returning a promise. We know that. Called response. And here, we're using that response to get the data out of the JSON. So this is returning a promise. And what does this end up doing? This ends up allowing the syntax for something that looks very synchronous. That's why it's so easy to use async await. Async await looks very synchronous. I don't even see a then, right? There's no then method. There's no, we're still catching errors, but we don't have to even do the dot then. We can just await this, then upon a successful response, the data would be loaded inside of our object here, const data, and then we can log it. Right, so let's kind of tie this in here. Let's refresh this. I hope you guys are still with me, because async await is what we will be using very soon. Okay, so here we have this asynchronous function. Notice you call it just the same. Okay, it has to be marked async because we are awaiting the fetch API. This returns an object called response. We then take that object, again, that object is not the data itself. You have to call the then method, or in this case, we're calling the JSON method to extract the data out. And then log the data, fetch products, and there you can see we're getting the data back. I mean, we used the fetch API last week, but we did not use the keyword await or the keyword async, right? Instead, we were doing dot thens. Here we are calling await fetch. Instead of getting a promise, our caller gets a response object back, just as if the fetch API were a synchronous function. We can even use try catch block, which we will do that, right? We will wrap our functions in try catches. See here, notice we got a big old try catch using async await. And why that's red, I don't know. Oh, they don't like that. Let's see if I would have read. Note though, async functions always return a promise, so you can't do something like this. Let's kind of, instead you'll need to do this. Oh, the difference being promise, fetch products. Oh, here you have, because this returns a promise, you have to use the then block there. Here it returns data. Okay. Okay, conclusions, and then we're going to write some code. Promises are the foundation of asynchronous programming in modern JavaScript. They make it easier to express and reason about sequences of asynchronous operations without deeply nested callbacks. And they support a style of error handling similar to try-catch statements, which you guys are familiar with. The async await keywords make it easier to build an operation from a series of consecutive asynchronous function calls, avoiding the need to create explicit promise chains and allowing you to write code that looks just like synchronous code. I could have just like gone right into the coding without explaining, getting into the weeds, but I feel like at least you guys should have heard this once, right? Because I could have skipped it and just not gotten into the weeds. But I hope for those of you who followed along, I hope you have a better understanding today of asynchronous code and promises. And again, we will be working with this all semester. Okay, so let's do something here. So we're at the council, we're back at the council, and just like council apps, you know, I'm going to give you some problems, simple problem like miles per gallon, right? And we're going to say, hey, ask the user for the miles they drove, ask the user for the gallons consumed, do a little bit of math, give me the output. Okay, this is just where we're starting, okay? Mainly just to show you that you can run JavaScript out of a browser when you have Node, okay? And so that's kind of what we're doing here. The way that we're going to do this, right, is with a read line let's see. Is it a library? Node, the Node readline module. Yeah, so it's a JavaScript file. The Node readline module provides an interface for reading data one line at a time. Right? This is what we're going to use. Every library, right? Whether it's C++, it's C#, it's Java, right? There's some sort of way of accepting input from a user. To use the promise-based API. Now, remember CJS? CJS is common JavaScript. ESM is, ECMAScript, ES, modules, right? So ESM are the newer module-based JavaScript. Common modules are the old JavaScript. CJS is new. ESM is, CJS is old, ESM is new. So you can kind of see here, the following simple example illustrates the basic use. Now if I bring this, if I change this, right? So there's a different syntax for imports. So notice here, if I change this to common.js, we're not using the import syntax. This class, the way I teach it is we use the newer syntax, okay? I will tell you, just a heads up, a lot of the documentation out there uses the older syntax. So, I view it as like, hey, let's start using the newer syntax, and because that's what's going to be going forward, right? So if you have to learn one, learn the new or learn the old, I'm going to choose learning the new. Even though a lot of the syntax you're going to see, the documentation still uses some of the old stuff, right? So I just want to point this out, everyone watching my screen. See this right here? This is the older syntax for importing modules, using a constant and using the require. All right, ES modules is a little bit different. So let's just kind of copy this in, right? Here, let me link this file to you guys in the Discord chat, so you have it. And what I'm doing is I'm kind of scrolling down to the following simple example illustrates the basic use of the readline module. I'm just going to copy this in, and you could see built in here, you got the await keyword. So I'm going to kind of go into here, and I'm going to swap out my index.js for this little bit of console JavaScript. Now again, your file needs to be MJS if you're using this newer syntax. So command line CLS, by the way, clear screen. If you're familiar with your command line commands, CLS, clear the screen. And I'm going to run this by typing in the node command, index, hit tab, in tab, index.mjs. And now we're prompting the user. I'll say it's fantastical. Okay, now again, you got a keyword of await. R1.question is actually how we prompt the user. Okay, so these 3 lines, imports and creating this interface, which by the way, we got a little destructuring going on inside of here, right? Here we're storing an answer. We are awaiting R1.question. So you know there's promises behind here going on, right? Upon the user, typing in something and hitting enter, it is stored an answer, and then we log, and then we close R1. Okay, well, why don't we do this? Const miles driven equals enter miles driven. Constant gallons used. Await, question, enter the gallons used. Miles per gallon is miles driven. Man, Copilot doing his thing. Let me clear the screen. Let me run the file, index.mjs, 100 miles driven, 33 miles per gallon, 3.03. Does that math check out? 3. I would expect 3333. The toFix is probably doing a little bit of rounding for me, so let me take off the toFixed. Let me run that again. 133. Isn't 100 divided by 33, 33.3 repeating? I mean, I know it's 100 divided by 33. Oh, my math brain is broken this morning.
So you gotta do 33 repeating, just divide by 3.
Yeah. That's what I did. I did 100 divided by 3.
You
Oh.
divided by 33.
Oh, that's what I did. I did divided by 33. Yeah, we're good. 100 divided by 3. Haha, there we go. Let's take a look. Okay, so once you guys can get here, basically this is problem solving like we've been doing the last year, right? Of here's a problem, and that's what the labs are going to be. There's like 3 or 4 labs, and I'm going to go ahead and open those up for you guys now.